Okay. So, this chapter, we've talked about area between curves. We've talked about volumes of revolution, where we take that region and we rotate it about an axis. Okay? Today, I want to talk about a region, and instead of rotating, I want to basically like raise shapes up out of the region, like you see up on the board, and to create a three-dimensional figure, and we're going to find the volume of that. Okay, so like that green figure, I think that's the easiest to visualize. We have a region bounded by y equals x squared, x equals a number, I think 1, and the y-axis, x-axis. And sitting in that shape are semicircles. Do you see the semicircles? Okay. So basically what our job is going to be is we need to figure out what the area of these shapes would be. So like in this case, we need to figure out the area of these semicircles. Well, that's kind of strange because it's going to vary based on where it is in the figure, right? And they're all going to have a little bit of thickness to them. So when we add them all together with their very small thickness, we're going to have volume. Okay, so we're adding things together with really small thickness. What do you think we're going to have to use? Calculus. Okay, and instead of a summation, though, we can make it an integral. Okay, we're past our days of having to do those Riemann sum things. Okay. Okay, but I want you to really like look at these figures. So like this purple one, there's rectangles. Okay, and here we have some sort of. So I might say like a right triangle where the hypotenuse is sitting there, or I might say an equilateral triangle, or there's a lot of different triangles I can tell you about. Okay, an isosceles triangle. Okay, but this is how we're going to actually find it, okay? We're going to figure out how to find the area of that shape, and the area is going to go inside of our integral with thickness dx. Now, what I do want you to write down is that I want you to write down what I highlighted in blue. If you're not going to write down the whole thing, okay? And then write down, of course, this formula. Okay, if we think of prisms, we think of finding the area of the base times the height. That's kind of what's happening here. This A of x is the area of that shape times its height, or its thickness, since it's so short, dx. And then we're adding those up all together. Okay? Now, each of those shapes will be varied, which is why we're going to write this in terms of the functions being used. And then our integral going from A to B will help account for all of that change. Okay. Now, notice how I said that these shapes were going to be perpendicular to the x-axis. Okay. If I were to change that statement to perpendicular to the y-axis, then we would have to do all of this, but in terms of y, and use dy. Thank you. Okay. So here again, I'm going to make you draw that rectangle so you can see what we're perpendicular to, and you know what variable you need to use in your integral. Okay. Also, what's going to be important is the length of that rectangle that you draw in, because that's going to be the base of whatever shape we're rising up out of our region. Okay, so go ahead and write down this example right here. We have the volume of a solid whose base is bounded by the graphs of y equals x plus 1 and y equals x squared minus 1, with the following cross sections taken perpendicular to the x-axis, and that would, our following is squares. Okay, I don't know why I just didn't write squares. I think I was going to do more than one example, but we're only going to do the one. Okay, with this region at least. Just write it down. Don't worry about visualizing it quite yet. Just write it down. That's your only job. All right. Y equals x plus 1. Looks like this, right? Okay. Y equals x squared minus 1. It appears that they intersect here at x equals negative 1. But what would be their intersection right there? I heard 2, I heard 3.
Well, like 2.
Oh. Yeah, gotcha. This is the coordinate 2, 3. Okay. All right, I agree with that. Okay, so let me go ahead and just highlight what's happening here. Okay, so here's our region right here. Okay, and in this region, we have shapes perpendicular to the x-axis, which means we have these rectangles drawn in here with thickness dx, and that's the base of our shape. So imagine this red strip that I just drew, and projecting out of my board is a square. And that's what's happening throughout this entire region. Yes?
Is it like getting smaller and bigger than smaller in that one? Or is it just smaller?
The squares?
Yeah.
Yeah. So like up here, if I drew a sliver here, then that square is going to be significantly smaller than this square.
Okay.
Yes. So it's, height-wise, you're going to see that it varies. Okay? And that would be true for all of them. Okay, so let's first talk about the base, okay? So the base for whatever we're working with is going to be the length of the rectangle that you draw. Okay? Well, we've been doing this over and over and over and over again, right? In this case, we just need top minus bottom. So our top function is x plus 1 minus our bottom function is x squared minus 1. Okay? That's the base of whatever shape it may be. Okay? Now, specifically, we're talking about squares. And how do you find the area of a square? Base times base, right? Like whatever the side is squared. Base times height, well, the base and the height are the same. Okay? So when we set up our volume, we're going to take the integral. Now we're doing this in terms of x, so we've got to go from -1 to 2 since that's where we have that's where our intersections are. Okay? Our area is side squared. Well, we know that the base is x plus 1 minus the quantity x squared minus 1. So our area of the square would be that square. Type it in Math Night.
Are you saying that answer squared is what it is, or that answer is the area?
This is the area because this is our base.
Right.
So for the area, we square our base.
Okay.
And so this that I'm underlining in green, that is the area of a square.
Okay.
What do we end up getting?
Units cubed. It's something.
Like exactly 8.1?
Yeah.
Okay. So 81 tenths or 8.1. Really, at that point, I don't really care what it is. Okay, because 8.1 is pretty nice, right? We're not multiplying. There's no pi involved. So it's just the number that you type into your calculator. Okay? And yes, I really liked how you guys are saying cubic units. You're right. Okay, it's volume. We are talking about cubic units. Okay? What questions do you have about this example?
So the base, that's what base?
The base of whatever our shape may be. So, whatever sliver we draw, that's our base. So it could be a triangle projecting out. It could be a semicircle. It could be a square. So my first step that I want you to do is I want you to figure out what the base is. And then from there, you can look at the area formula based on whatever shape you have. But no matter what, you're going to have to figure out the length of that rectangle right there.
How are we going to know if it's a triangle if we've only been dealing with rectangles?
Sorry, I thought that was going to be a triangle example. Okay, you're always going to draw this as a rectangle. It's going to be this that's going to change. Okay? All right, so now let's try this one. Notice how we have sections perpendicular to the y-axis. So if you're going to condense this down to not as many words, which I would suggest you do, I would write down y equals x and y equals x squared, but then I would write perpendicular to y-axis because that piece of information is important. And it looks like we're going to do rectangles whose height is twice the base. So here's our region, right? Y equals x and y equals x squared. But I'm asking you to go perpendicular to the y-axis, which means our thickness is going to be dy. Okay, well, let's go ahead and label these equations since we have to change them. So instead of y equals x, we want to think of this as x equals y. And instead of y equals x squared, we would want to think of this as x equals, in this case, positive radical y, because we're on the positive side. Okay. Doesn't even matter what the shape is. Your first step, I need you to figure out what the base is. What's the base length? So before we make this into a three-dimensional figure, what is the length of this sliver that you just drew? Okay, well, since we're talking about y, we need to do right minus left. So our right function is radical y minus our left function is y. Okay. Now let's actually think about the shape. So what's happening is we have rectangles that are going to like grow out of the board here. And it says the rectangles whose height is twice the base. So they're going to be long rectangles. They're going to be very tall rectangles. Okay? And like I think is it Grace asked, they're going to be varying in height based on where you are in your region. Okay? So if we're talking about the area, we're talking about base times height because we're talking about a rectangle, correct? Okay. Well, but we do know something about the height of our rectangle. Okay. So you can do one of two things. You can go ahead and you can go to your volume and you can say, okay, well, what are our intersections? 0 and 1. Okay, they were so trivial I didn't even talk about them. Okay, so the area would be the base times the height. Well, it says that our height is 2 times whatever the base was. So here is my base. 2 times the base is my height. So you can leave it like that. If you want, feel free to rewrite it like this, 2 times the base squared, because that's what's happening. But I'm okay either way. Okay. And then from here we can find our volume. Go ahead and do that in Math 9.
So we always get our calculator for these ones?
I would not say always, but the ones that we've done so far haven't been ones that I would necessarily want you to do by hand. What I could do also on a non-calculator problem is ask you just to set it up. So this is a problem I could easily put on a no calculator section and say set up but do not evaluate. Kind of like I've been doing on our warm-up problems. Okay, what do you end up getting for this? Probably something not very pretty, right? I heard mumbles.
0.06, and then like the 6 is a 0.
And 6. Yes.
Okay, that's got to be some type of fraction.
No, I'm going to this.
It's not. It's like it's 788 at the end. But it's just too long to write out.
There's a bunch of 6s.
There we go. Okay. It makes sense, right? We got a pretty small region going on there. All right. One more example. We have 10 minutes, so it should be plenty of time. Okay? The shapes we've done haven't been overly strenuous, have they? I mean, square. Yeah, we're going to do a semicircle.
Oh,
If you go back to the first two examples that we did, I'll come back. So our shapes haven't been very difficult to picture, okay? It might help you to draw a picture when we get to some other shapes. Like here's our square, where this is the base that we found up here, okay? And over here we had rectangles, right? Where this was the base that we found. It may help, and I know these two didn't really require pictures, but you may want to draw a picture and label what your base is if you need that reference, okay? So let's talk about this picture right here, and you're going to need your calculators to help on this one, because we have radical x and we have e to the x. Do you want to solve for that algebraically? Probably not. So you'll need to use your calculator to actually find this intersection point. So I'm going to let somebody do that for me. I need the intersection here. Sure, what's this coordinate?
We got 0.426, 0.65.
Okay, so what's going to happen is, so we said perpendicular to the x-axis, so I drew in my rectangle with thickness dx. I don't really have room to label it, but there we go. Okay, so let's talk about the base. We don't even care about the shape right now. Let's just talk about the base. The base is whatever rectangle you draw in here, okay, with thickness, in this case, dx. So top minus bottom, our base goes from e to the negative x to radical x. Okay. Now, when we go to talk about the area of that shape, we're talking about a semicircle, right? So here's our shape where the base is the entire diameter. Well, how do we find the area of a semicircle? 1/2 pi r squared. And our base is acting as the diameter. So when we go to actually calculate the volume, okay, we're going to go from 0 to 0.426 because those are our x intersection, or well, yeah. And we want 1/2 pi r squared for our area. So we'll have 1/2 pi. Our radius is going to be half of the diameter because that is how we calculate radius, right? So 1/2 pi r squared, and then our thickness dx. Bless you. I'll let you punch that all in. Let me know if you have an answer for me.
Why is it over 2?
Because this would stretch the diameter of our semicircles, and for the area of a circle, we want pi r squared.
Oh, okay.
So we cut the diameter in half for our radius. Something that is very easily overlooked. All right, what do we get?
Only 1, 2, 7.
Do you agree with that?
That's what I got.
Oh, yeah.
Okay, what was your mistake, Aaron?
I forgot to square the radius.
Oh, don't forget to square the radius. Somebody else did the same.
I made the same mistake.
It is important. So if this were on a quiz, if you had the right setup but not the right answer, I would give you a point. I would take off a point for misentering it into your calculator. So make sure you're very careful about at least writing it down so you get those points. Okay? Yes.
Do you have to know how to like trace it on your calculator and find the intersection? Can we do a little refresher on that?
In your calculator, if you have each of these graphs, like for this right here, so we have second trace,
Yeah.
the intersection, and then just move your cursor until you're at what you think the coordinate is, and press enter 3 times.
Oh, so just kinda weird.
And then it'll give you, because it like asks you for the guess.
Oh, wow.
Did it give it to you?
Yeah.
Alright. Anyone else need help with that? Okay, yeah. Usually we do a calculator worksheet in between these 2 chapters, but the snow days we didn't have time to fit that in, so we're going to do it after spring break. So we'll get more practice. Yes.
Yeah.
Oh, I thought you had a question. Okay. Now, we're not going to do another example, but I know there's going to be a problem in your homework that has triangles, and it will be very important for you to draw this picture and label the base so you can figure out what the height is based on the base. Okay? You may have to use some trig, yes. Oh my gosh. I think you have, how many problems do you have? 2? 3? 3. They have multiple parts, but,
Whoa.
oh, there's 3 total, okay, that are required.
Yeah.
If you feel iffy, do some non-bolded problems. Okay? Tomorrow we will review for our quiz on the next day. I'm going to say days anymore.
I was going to